All right, we just learned about 3 rules of exponents, and now we're going to see 3 laws of logarithms that correspond with those rules. So let's look at the laws of logarithms. The first one says if we have a log base A of a product, capital A times capital B, we can actually write this as the sum of 2 logarithms, log base A of capital A plus log base A of capital B. So in words, the logarithm of a product is equal to the sum of the individual logarithms of the factors. And this is equivalent to the corresponding rule of exponents, a to the u times a to the v equals a to the u plus v. Another situation where we have a product that ends up being expressed as a sum. Let's look at the second law of logarithms. This one says if we have the logarithm of a quotient, we can express this as a difference of logarithms. So we can take the numerator as the first logarithm and the denominator as the second and express it as a difference. This is equivalent to the rule a to the u over a to the v equals a to the u minus v. Another situation where we have a quotient that can then be expressed as a difference. Now, a third rule of logarithms says if we have a logarithm of something that's raised to a power, we can actually bring that power to the outside of the logarithm as a coefficient. So this is equal to c times log base A of capital A. And again, this is equivalent to one of the rules of exponents. Here we have a to the u raised to the v power equals a to the u times v power. We've got a power on something, and in the end, we're expressing it using a product, which is exactly what happened here. These are the 3 main laws of logarithms that we can use in a variety of situations. Sometimes this helps us evaluate logarithms. Sometimes this helps us simplify them. Sometimes this helps us expand them. But I want to start by looking at just a few basic examples of where this can help us do some calculations. So here, we're going to have some situations where we're evaluating expressions. So let's look at log base 6 of 2 plus log base 6 of 18. Now 2 and 18 are not nice powers of 6, so these aren't things that we can evaluate on their own in our heads very easily, but we can apply the first rule. It says that if we have a sum of 2 logarithms with the same base, we can combine them into one logarithm by taking the product of the insides. So this will be log base 6 of 2 times 18, which is 36. And now we have a logarithm that we can evaluate. What power do we raise 6 to get 36? Well, 36 is 6 squared, so the answer here is 2. This is one situation where using a law of logarithms allowed us to easily evaluate something that we could not have done in our heads. Let's look at another example. Let's look at log base 2 of 80 minus log base 2 of 5. Again, we have logarithms that we cannot calculate in our heads because 8 and 5 are not nice powers of 2. But we can use the second law of logarithms here, and we can express this as a quotient, 80 divided by 5. And then we can actually evaluate that quotient. 80 divided by 5 is 16, and log base 2 of 16 is 4, because 2 to the 4th power is 16. Hopefully you're seeing how this is useful. Let's look at one more example just with numbers, and then we'll see a couple of situations where we can use these in more advanced logarithms. So the next one is going to be 4 times log base 9 of 3. Now, we can actually evaluate log base 9 of 3, but it's going to be a fraction, and that's a little bit unnecessarily complicated. So we're going to use the third law of logarithms to show that when we have a coefficient out front, we can bring it inside as an exponent. So we can rewrite this as log base 9 of 3 to the 4th. Now we know that 3 to the 4th is 81, and log base 9 of 81 is just 2, because 81 is 9 to the 2nd power. So this is another situation where we can make things simpler by using one of the laws of logarithms. Now I want to look at two more situations where we can use these laws of logarithms. One of them is to expand an expression. So for example, we could look to expand log base 5 of x cubed y to the 6th. Now here we have the logarithm of a product, so we can split this up into the sum of logarithms. So we can write this as log base 5 of x cubed plus log base 5 of y to the 6th. And now we have two situations where we're taking the log of something with a power, and we know that we can take those powers and bring them out front as coefficients. So we could write this as 3 times log base 5 of x plus 6 times log base 5 of y. There might be situations where it's important for us to have the logarithms being as simple as possible with the least amount of things inside of them instead of a complicated expression in there. So in this case, we can use the laws of logarithms to expand a logarithmic expression. We can also go in the other direction, and we can simplify a complex expression that has multiple logarithms into one that only has one logarithm. Let's take a look at 3 ln of x minus 1/2 ln of x plus 1. Now here we can start by taking the coefficients out front and bringing them inside the logarithms. So we can rewrite this as ln of x cubed minus ln of, and when we raise something to the 1/2 power, that's the same as taking the square root. So we can write this as the square root of x plus 1. And then when we have a difference of logarithms, we can write this as the logarithm of a quotient. So we can combine all of this into one logarithm, ln of x cubed over the square root of x plus 1. So we've taken an expression that had two logarithms and coefficients nonetheless, and we've combined them into a single logarithm, which is simpler than what we started off with. There are different scenarios where we might want to expand or simplify an expression with logarithms. We'll see some of these later, but right now we just want to get comfortable dealing with these laws and dealing with logarithms so that we can prepare ourselves for more complicated situations, including word problems, as we move forward.